Okay, picture this. The very heart of the internet, the powerhouse behind AI. What if it wasn't in some huge building on the ground, but was actually orbiting high above our heads? I know, it sounds like something straight out of a sci fi movie, but this is a very real idea being worked on right now. So let's break down what this could mean for, well, all of us. And look, you gotta understand, this isn't just some far off futuristic dream. The people actually building this stuff, they see it as a genuine turning point in history. I mean, listen to this quote from Chris Stott, a CEO who's already deep in this game. He's comparing it to the Wright brothers' first flight at Kitty Hawk. The ambition here is, well, it's absolutely world changing. And seriously, this isn't just talk. It's already happening. Just this year, a company called Lone Star Data Holdings actually sent a data center flying past the moon. They successfully tested a data payload out there in deep space, proving that, yeah, you can store and process data on its way to the moon. An event like that, it completely shifts the conversation from if this is possible to when it's going to be mainstream. So, that really brings us to the core question, doesn't it? Are we really looking at the next giant leap for our digital world? Or is this whole thing just a super expensive, technically insane dream that's, still light years away from being a real thing? So why? Why would anyone even consider such a wild idea? Well, the dream is to solve some of Earth's biggest tech problems. Think about it. Data centers down here are just insatiable. They guzzle power, water, and land, and all of those things are getting harder to come by, especially with the crazy growth of AI. But in space, you've got unlimited 24/7 solar power, and you don't use a single square foot of precious land. Sounds pretty good, right? Okay, so that's the dream. But you know what comes next, right? The cold reality check. And the first huge, huge problem is actually it's a hot one. It's all about how you get rid of the incredible amount of heat these servers crank out. And this is where things get really counterintuitive. You'd think space is freezing cold. Cooling should be easy. But as experts like Dylan Taylor point out, that's the exact problem. There's no air, there's no water, there's nothing to carry the heat away. So the processors just sit there, getting hotter and hotter and hotter. It all comes down to a fundamental law of physics, the Stefan Boltzmann law, to be exact. See, here on Earth, we just use fans to blow air or pumps to move water to cool our computers. Simple. But in the vacuum of space, your only choice is to radiate the heat away. Think of the red glow from a hot stovetop burner. That's radiation, and it is a shockingly, painfully inefficient way to get rid of heat. And just to give you an idea of the scale we're talking about, it is staggering. To cool just one pretty small 2-megawatt data center in orbit, you would need radiators with a surface area of almost 4,000 square meters. Let that sink in. That is the size of 15 tennis courts. 15. And that's not for the computers. That's just for the cooling system. Okay, so you've got this gigantic cooling system the size of a sports complex. And that leads us straight to the next massive challenge, the billion-dollar price tag to get all that stuff into orbit in the first place. The physics is tough, for sure. But the economics might be even tougher. Let's just look at the numbers. Right now, if you want to launch something on a super reliable rocket like SpaceX's Falcon 9, it's going to cost you almost $3,000 for every single kilogram. But look at the target price for Starship. They're aiming for less than $100 a kilo. That's not just a little bit better. That is a complete, total industry redefining game changer. So here's the bottom line, and it's a big one. The entire business case for putting data centers in space, it completely hinges on one single rocket, SpaceX's Starship. If Starship doesn't hit those ridiculously low-cost targets, this whole idea just stays a niche, super expensive service for governments and a few special customers. The dream of this becoming a mainstream thing, it pretty much lives or dies with Starship. Okay, hold on. If these things have massive cooling problems and they cost a fortune to launch, why are incredibly smart people pouring billions of dollars into them? Well, it's because we've kind of been asking the wrong question. The point isn't to replace the data centers we have on Earth. It's about a totally different mission. Let's think about how satellites work right now. It's kind of clunky. A satellite up there collects terabytes and terabytes of data, say images of the Earth. Then it has to wait until it's flying over a ground station to slowly, painstakingly beam all that raw data down. That connection, it's a huge bottleneck. Then we process it all on Earth and send the useful bits back up. It's slow, and honestly, it's super inefficient. So here's the new mission. Process the data at the source. Do the computing right there in orbit. Instead of sending a whole terabyte of raw images down, you process it up there and send down just the answer, You send the insight. Hey, there's a wildfire starting here, or there's an illegal fishing boat at these coordinates. You're basically turning a giant fire hose of raw data into a tiny trickle of pure, actionable information. And that is where it all clicks into place. We're not talking about putting Netflix servers in orbit. This is for really high-value, critical stuff. We're talking about real-time Earth observation for climate change, instant threat detection for national security, creating disaster-proof data backups that are physically separate from the planet, and yeah, even training massive AI models using that free, nonstop solar power. So, with that real mission in mind, what does the future of this whole thing actually look like? Well, it's not going to be some big overnight switch. It's going to be more of a gradual evolution, happening in stages. The experts who follow this stuff see it unfolding in distinct phases. Right now, we're in the demonstration phase. We're seeing the very first test flights and proofs of concept. Over the next decade or so, we'll move into an early commercial phase. After that, a huge growth phase. And by the time we get to 2050, this could be a multi-trillion-dollar industry. It's a long game. And believe me, it's not just one or two startups dreaming about this. There's a whole ecosystem popping up. You've got Lone Star pushing the envelope with data storage on the moon. You've got StarCloud, who just put a powerful NVIDIA AI chip into space. Axiom Space is building data centers for their new commercial space station. And even Europe is getting in on it with a project called Ascend. The race is definitely on.
So if there's one thing you take away from all this, let it be this. Orbital data centers are not going to replace the ones on Earth. It's not an either-or situation. They are a different tool for a completely different set of jobs. If you need super low latency for your video games here on Earth, you're going to stick with a local data center. But if you need to crunch massive amounts of satellite data, or you need ultimate physical security, or you need access to unbelievable amounts of clean energy, that's when you're going to look to orbit.
And that really leaves us with a pretty incredible final thought. I mean, think about it. For every single moment of human history, all of our knowledge, all of our information has been stuck right here on this planet. We are standing at the very, very beginning of an era where that might finally change. So the question isn't just about tech anymore. It's about our future. Will our digital civilization, everything we are, stay here on Earth? Or is it destined to expand with us, out among the stars?